Okay, I'm going to give you guys a little rundown on how to track down a problem, and y'all may have some remembrance of some of this thing from last semester, but at the same time, you're going to benefit from knowing this. This one right here was one that came into the shop, and this is actually the service bay where I worked before I came here. This is where I worked right here in the next shop and all that. And that little car right there is a little Escort, and the lady was complaining that the speedometer didn't work sometimes, and the transmission wouldn't shift and all that. And so they give it to a mechanic down the line, and basically he threw a vehicle speed sensor at it. And whenever he first threw the vehicle speed sensor at it, he drove it, and it seemed like it was okay. The speedometer's working, transmission would shift and all that. She gets the car on it before she even gets out of sight. Speedometer's back on 0, and it's not shifting again. And so, as typically sometimes whenever that would happen, they would just throw it and try to get it straightened out. And so I actually plugged in. This is looks like our IDS that we got in there now, but I couldn't get any communications out of the PCM. I was just going to check and see, can I see the vehicle speed sensor on there? You know what I'm saying? So here we go. And so I'm saying, back this was Worldwide Diagnostic System, but it had the same programming that the IDS does, which they called it WDS back then. But you can see the tabs look the same and all that kind of stuff. All right, so in a diagnostic PCL, this is going to do you some good for electrical and for engine performance. One of the things you need to remember is that terminal right there on your DCL. If your scan tool won't power up, you need to check and see if that terminal right there is hot. That is pin number 16. Okay, you got that? You should have battery voltage there. Usually it's powered up through the cigarette lighter fuse. Okay, so if your cigarette lighter fuse is blown because people dropped a penny down in there and popped a fuse or something like that, you're gonna have issues. So that one right there, if that one's got hot, these two right here, pins 4 and 5, those are ground. That is common to every DCL that I know anything about. Now that data communication link right there, that particular trapezoidal thing, that has been on part. The first time I ever saw one of those was in 1994 on a Thunderbird, and by 1997, just about every car in the country had a connector under the dash like that. Now something else I want to tell you is, you remember I told you there's two different rooms. There's an OBD2 room, and there's a OBD2 enhanced room, and then there's a generic room in the engine controller. They even talk over different wires, all right? And that sort of thing, sort of changes from one to the other. You got a couple of wires here and one down there and all that. But the long and the short of it is that one and these two are the constants. Both of these are supposed to be ground, and that one right there is supposed to be hot. Now get your test slat or your OBD breakout box, which is a breakout box you can plug into this, and it's got little pins out there so you can hook up to them. All right, now right here, what we got, here's your data link connector right here. You notice 4 and 5 are ground, like I was talking about, and 16 is hot. Now these other ones are basically, there's 3 of them, 13, 10, and 2 come from the powertrain control module, and 7 is that little, that other network, it's a little single wire network that comes, their ABS control, your route module, your remote aided personality comes from there. One way or another, I got no communication whatsoever. And so basically what I had to do was go after this way. And so there's your little, you got these pins laid out and all this. I already went through that again and all that. So like that. I would want to see if the data stream was active. So I basically connected a scope, this little scope that I had at the time, up to the data stream, and with the scan tool plugged in and the engine controller trying to talk, I actually got this signal. I had a nice little, signal going on there. Now, I'm not going to be able to tell you anything other than the fact that because I see that pattern there, I know that it's trying to talk. That's basically all. That's how when you're doing any bus diagnostics, you're basically going to hook up and you're going to see what your bus looks like. And if you know what the bus looks like and you know what your voltages are, you'll know it's supposed to be 2.5 up this way and 2.5 down that way and all that. And some buses, if there's a 2-wire bus, some of them will work when one of the wires is cut, some of them won't. There's a whole bunch of different stuff on that. Different speed buses and all that. Here's a map of the speed sensor circuit. All right, there's your vehicle speed sensor that he replaced right there. Okay, so that one right there, you got ground, you got vehicle speed sensor input right here. And this is the instrument cluster, right? So the vehicle speed sensor is talking directly to the speedometer. And so I go to these two terminals right here. You see how I told you the other day we're going to go find which terminals are what? So when I unplug that connector and I'm looking into it, I'm going to make sure that my wire colors are matching up. What color is that?
Black.
What color is that? No, that's blue. BL is blue. On this particular one, BK is black. BL is blue. On the Asian cars, L is blue. On a German car, SW is black. So because that's, Schwarz is, black in German. All right, so anyway, here we've got, this is what it looks like when you're at the, I'm actually going into I'm back probing that connector so as not to damage the terminals with my pins here. And there's enough room to put those pins in there without messing them up. So I got 216 ohms, which is what the vehicle speed sensor is supposed to have. You got me? Now when you're measuring ohms, it's a good idea to take the battery cable off, because whenever there's a little bit of current flowing through those cables, it can cause your meter to read screwy. You don't want your meter to read screwy. So you basically take your battery cable off, and you go to the two wires that goes directly to the vehicle speed sensor, and I want to measure that. That way I know if I've got a good connection all the way, right? Over there. So when I looked at the battery terminal, this was a nasty looking, rusty, chalky battery terminal right here. This ain't good. That don't look good, does it? You ever see a nasty, chalky battery terminal? Anybody that's never seen a nasty, chalky battery terminal has not opened the hood on very many cars, because you're going to have a lot of them. All right, you notice you also got this little bunch of other wires that are hooked up here. Oh my goodness, when I unplugged that, look at what I had here. Now on that schematic, you might have noticed that these wires right here are actually the ones that are going in there to the data link, and they also ground the speed, the vehicle speed sensor and all that. And so I said, well, this acid wicks up in that cable. I cut that cable, and I got a worksheet I'm going to give you all where you're going to, take a piece of cable and you're going to solder it into a terminal. You've done that before. That's pretty good stuff. Ain't hard to do, and it's a permanent repair when you do it, if you do it the right way. All right, so we got this chalky junk right here. So you got to keep clipping the cable back. I have clipped about that much back into the cable and found that stuff. Does anybody here know what capillary attraction is? You know how whenever they prick your finger at the doctor's office and they got this little thing and they hold it and the blood shoots up in it? That's capillary attraction, is what that is. Or if you're a diabetic and you check your blood sugar, you just make a little bubble of blood on your finger and stick it up and it shoots up in that little thing. That's basically what the same thing that happens with this acid here goes up in there and starts to attack that copper. Well, we go back far enough. That's how you do that. You basically take that thing and you heat it up and you stick solder down in there until you got molten solder, and you've actually got a little puddle of rosin on top of it. Don't ever use acid core solder to fix wires, or you'll make a bigger mess than what you already got. Rosin core solder. The rosin is in the center of that solder. When you melt it, you're going to see this brown stuff that's burning here that's on top of that solder. And while it's still blistering hot, you stick your cable down in there, and that grabs a hold of all that copper, and you got a good solid connection there that ain't going nowhere. Well, what I like to do too is I like to take all the other wires. Like if I got 3 or 4 black wires that were just plugged in, I'm going to take some other wires and I'm going to put those in there too, along with this, so that they're all coming out, and you got the big one and you got a bunch of little ones coming out with it that you can hook onto your other grounds. And what I did when I clipped it back to where I needed to go, I put these wires together, sort of wove them together, and then I used my same torch and I went ahead and soldered that wire together, and then I put some good solid heat shrink on it that would ooze out that stuff that protects it from oxidation. All right, so this is what it looked like when I got through fixing it. See, I had all these wires. I had a piece of heat shrink tubing on that, and I had those 3 wires out there hooked to these wires right here, so that all of that stuff, now we had a good solid ground that would never give trouble again unless somebody did something stupid. All right, that took care of that. Ta-da! All it had to do, my scan tool went to talking. See, one of the grounds going to the data link connector didn't have a connection either, so it didn't have a reference point for its data link. Here's another speedometer problem. Speedometer inoperative, overdrive light flashing, check engine light on. It's on this truck right here. All right. All right, so we had a dead needle. Powertrain control module gets its speed signal directly from the speed sensor. Now, when you're doing something with a speedometer, something like that, you need to know, how does the speed sensor signal get to the cluster? You got it? Because sooner or later, you're going to be fixing gauges. Let's just be real, all right? On some of the mid-2000s Chevy pickup trucks, we'll actually take the clusters apart and replace little stepper motors in them and lights and stuff like that. It's pretty cool little job. Doesn't take that long. Doesn't cost that much to do it. But anyway, the PCM depends on the speed signal for transmission shift strategy, and since the PCM illuminated the check engine light and began flashing the overdrive light, that means the signal wasn't there. That's basically telling you the transmission has got an issue whenever your overdrive light starts flashing on the truck because it's vintage. Alright, so the scan tool threw me a P0500 code. I drew me a scan tool here. Can you see it? Do you like my scan tool? That's pretty cool, isn't it? Alright, just what I expected. And a quick look at the live data showed 0 reading for the vehicle speed sensor. We had nothing. The check engine light, the flash and overdrive indicator, when they're both activated, they indicated a problem has arisen that will affect fuel emissions and transmission strategy. I had a Taurus I was driving one time, and the vehicle speed sensor occasionally would just quit putting out for a second and drop back into low gear. Because it's going to react to the vehicle speed that it senses. Okay, you got that? All right, so here's what you got. Powertrain control. There's that. Now this is your basically you're looking toward the engine, right? That's the output. The extension housing on the transmission, and that's the that vehicle speed sensor. Those are oxygen sensor connectors up there, and there's some cross members down here and all that hogwash. But the long and short of it is, and you know that looks like exhaust going across there. But here's the vehicle speed sensor, and that's what it looks like on the truck. See that? You got that? You notice you got a ground here, and you got a gray-black wire there. All right. So since the speedometer was the only part of the cluster that was inoperative, and it shares a fuse with some of the other components, a quick visual inspection of the speed sensor was over. When you're looking for stuff that's, if you've got something that's not working and you suspect that it might be a ground or a common power or maybe a fuse, if I'm looking and I've got a whole bunch of other things that's fed by the same fuse that works, then you can pretty well forget about that fuse being a problem, right? In other words, if this, and this is all fed by the same fuse and only one of those items is not working, forget about the fuse. Understand? You got that? That making any sense? All right, so no evident damage to the wire. Sometimes dogs and rats and squirrels and all that kind of stuff will eat wires. Okay, they do that. I'm sorry, this is what they do. And you got to fix it. All right, so basically what you got right here, this is the speed sensor, another little place right there where you're looking at the speed control servo amplifier. It draws that too, because this has got speed control because it doesn't have electronic throttle control. And you see that you may see the speed sensor pictured feeding different components if you go to different schematics because it's just, wired in, it's got its finger, a bunch of stuff. Look at the generic electronic module. It actually gets that too. And there's your PCM, it gets it. You notice it comes off and goes to the rear air suspension module, and it goes to the instrument cluster. See how it goes, it makes it through all that stuff. They just take that gray-black wire and they feed it to all this other stuff that needs it too. All right, and see there's your little, I actually colored those red showing you what all that feeds, And so, I checked the speed signal delivery. Pull the dash panel. That means first you got to, watch this is pretty important. You see that right there? Whenever you pull that out so that you turn on your fog latch, you stick your screwdriver in there, and then you pull this knob off on this. This is like 97 up to about, 02, I think. When you flip that around and stick it on there, and you turn that knob, it releases the catch and you pull that out of there. Now, if you ever go in there with a screwdriver and you try to pry this out of the dash, you're going to bust something, okay? Know how to do it. Pull it out so the fog lights are on, release that button with that screwdriver, pop it off, flip it around, you notice? And then I turn the knob, and it pulls a little thing in there. You just pull that thing out with your finger. All right, but there's a screw behind it. That's why you got to do that. All right. Okay, so I got all this connector right here. I got a C237, a white connector. Make sure you're looking at the circuit numbers and the wire colors. Anybody see the one I'm looking for right here? You see it anywhere? Gray-black, 679, pin 7. All right, so here I was going into pin 7, looking for anything that I might find for voltage. Now, what kind of signal does that thing put out? It puts out AC voltage. Okay, so you got to set your meter on AC. And this, since a lot of these meters, have really high AC settings, you're going to have to make sure that you jack the truck up and get the wheel spinning, so you can read that signal and see if you're actually getting an AC signal. All right, so speed signal 5x5. That's military code talk for good communication, right? Anybody that's in the military knows that, right? Okay, so the AC meter is reading voltage. I'm reading 3.579 voltage. That's not. That's a $300 meter I bought from the Mac tool bin. And I'm just reading from ground to right there, and I'm picking up 3.5 volts AC, right? Notice it says AC on there. All right, and so I reconnected everything, and that reboots all of the, you know, hardware and all that stuff. And now all of a sudden, after I plug everything back in, the doggone speedometer goes to working. Now what you gonna do? I don't know how many times I've unplugged something, plugged it back in. You ever seen these things where somebody would send me an email and they say, my Dodge, a bunch of the electronics aren't working, door locks, whatever, speedometer, instrument cluster, and all that kind of stuff. And I said, what you're gonna do is you're gonna pull both battery cables off and touch the battery cables together. And that empties all the capacitors and lets the computer forget any trash that may be in its memory. And you put them back on there, and about half the time all that stuff will wake up and start working again. And I've had people who say, hey, that took care of it, you know, and all that. So, all right, so this cluster is driven by a microprocessor. Escort speedometer is electronic, but it's not microprocessor driven. Microprocessors sometimes need to be rebooted. Let the cluster CPU lose whatever trash it had stored. When in doubt, reboot. That wasn't very long, was it? All right. Now then, what I want to tell you guys about is, are you getting the other thing I told you about how to find out the circuit and the wire and the connector? Go to the connector and make sure, if the best way to check, like for example, on like an ABS concern, if you've got a, let's say you've got a an ABS signal. Think about how you're going to handle this. All right, you got 4 ABS sensors, right? And those ABS sensors are going to the ABS module, typically. All right, so let's say that you've got a code that you pull for right front wheel speed sensor. All right, what's your next thing you're going to do? Right front wheel speed sensor code. What you going to do next? Somebody throw me something. You didn't say anything loud. What's that? Check the fuse that goes to the, you don't have a fuse going to that one. It's just got 2 wires going directly into the ABS module. What's the most common thing that you think might be wrong with it? Huh? No voltage. Well, it depends on the vehicle. Does the ABS sensors, some of them have to have voltage fed to them. Like on that Dodge Caravan, it's got to have 12 volts fed to it in the ground, and it's basically it puts out a square wave signal. You know, it switches between 7 and 14 milliamps as the wheel rolls and all that. It's difficult to read that too, huh? Huh? The sensor's faulty. Well, that's a good question. How am I going to check and see if the sensor's faulty? If it's a variable reluctance sensor like this one right here, I'm going to be able to measure it with my ohm meter. And you're going to see, you know, like 1,000, 1,200 ohms, something like that. If I measure it and I see that it's good, it's a good sensor here, what do I do next? I've measured it and it's good. Let's say that that's happened. But I'm still getting that code. What's your natural thought process here? This is electrical class. Now you're supposed to be able to think.
Disconnect the battery and clear out the code and see if that works.
Well, that typically won't help you if you've got, as a matter of fact, on those right there, when you switch on the key, they'll usually fire some voltage down there to everything and just see if it comes back. And if it doesn't, they'll know that that component's bad. Like for example, if you don't have one side of a component grounded and you shoot voltage down the other side, it does that with the airbag, it does it with solenoids, it does it with sensors, like them wheel speed sensors and all. If it shoots a little whisper of voltage down there and it doesn't see it come back, it's going to assume that you've got an open circuit. So what else is a part of that circuit other than just the sensor? The wires between the thing. So why don't we take let's go to the actual, the next easiest place to go. Let's plug that sensor back in after we look at the connectors and make sure somebody hadn't, you know, rammed this in there and spread the terminals. We don't want that, you know what I'm saying? So let's make sure that the terminals have got good pin fit. As a matter of fact, they've got whole kits you can buy of terminals where you can check pin fit, but you make sure you use the right one. Use the wrong one, you'll make a mess. And then you'll have no good connection nowhere if you check a whole bunch of connectors. Can you imagine spreading every connector in a doggone microprocessor? Ooh, that's scary. And it happens. Okay, so we're going to go and I'm going to unplug this connector, and I'm going to find out by looking at my schematic and looking at my connector pinout which 2 terminals goes to that particular sensor. Okay? Right? That makes sense? Alright, so I'm going to get on those 2 terminals. You know, I'm going to take a little piece of wire or whatever and go to those terminals so I make sure I'm in them good. And then I'm going to check those, and I'm going to check for continuity right here. once again, I like to disconnect the battery when I'm doing that, so I don't have whispers of voltage coming there screwing up my readings. And I'm going to see if I've got like 2100 ohms or whatever I had at the sensor, it'll be really close. And I'm reading right here at the place where that signal is delivered, which is very important. You need to know that. Okay, so I had this Explorer one time, and I measured right there where it delivered, and I had the same all the way down, but it was telling me that that sensor was bad. So what do you do now? Oh, by the way, the anti-lock brake module is $1,200. So you don't want to just throw one of those on there. But from what you're able to tell, you got good pin fit, you got good circuits, there aren't any broke wires, you got a code that's getting to you for, it's saying that the right front wheel speed sensor, or whichever one, is bad, and you're checking it right here at the actual thing, connector plugged into the module. Those two wires are showing you that that whole circuit is it's like it's supposed to be, yet you're still getting that code. Sounds like a bad module, doesn't it? All right, so what you're going to do now is I'm going to use my expertise in being able to deal with connectors, and I'm going to unlatch those two wires, and then I'm going to unlatch the wires from the other sensor on the other side of the vehicle that's not throwing a code, and I'm going to swap them, and then I'm going to plug it all back in, and I'm going to check it again. Now if my code moves, then I know I've got something I've missed on that circuit. If my code stays the same in the same place, if it's still telling me the same one is bad, what's that tell me? We got a bad module. Now we know the module's bad because we've got a connector. I mean, it didn't flag that left sensor, and we put the left sensor in the same two cavities the right sensor was in, and it's still telling me. You got to make sure you get your polarity right. You got that? You understand that? Okay. I mean, you see how common sense this stuff is, but you have to have the fine motor skills to be able to unlatch those terminals and get them out and get them back in there and be able to put them back right back where they go. And on that particular one, I had to put a module on there. Now, you cannot use an ohm meter to check these modules that are Hall effect modules. I mean, Hall effect sensors, right? Hall effect sensors, you can't check them with an ohm meter because you won't get a good reading anyway. But what you can do, even on the ones like on a Dodge, you can basically take your, measure the voltage on that wire going to that sensor with your meter and have it on a really low setting, and as you roll that wheel, you'll see that voltage deflect. You got it up and down? I'm going to show you all that. I've also got, I built one of these little transducers that we can check the pressure in the cylinder with, all the cylinder pressure, wave pressure. I built one of those things. I'm going to show you guys how you can build one. It's like a $500 to $1,000 tool, and you can build one for like 40 bucks tops. Pretty good deal. I'll show you how I did that. Okay, now, is everybody getting what I'm trying to say? When you've got, this is speed sensor stuff, right? When you got a speed sensor, you got to understand that whole circuit. Or if you got a solenoid, understand the whole circuit. You say it leaves here, it goes down there, it comes back, nothing to that. If I got one solenoid and I can measure that solenoid, the two wires, and I make sure you're on the right ones. If you get on the wrong ones, you may go off in the left field. But that's how you're going to do that. If it's a light, if it's an oxygen sensor heater, it doesn't matter what it is. If you've got one side that's hot and the other side that's grounded, it's very simple to check that. On a relay, like he was drawing over here, see that relay over there? Those relay coils the same way. The relay coil is going to have power on one side, it's going to have a ground on the other side, it's going to be delivered usually by a module or an engine controller or something like that. And what are you supposed to have when you unplug a relay? You got to have two powers and two grounds at that relay socket whenever the relay is supposed to be energized, right? Two grounds being one's the coil and one's the load, because you got the relay out of there. The load's going to show you a ground if it's good. And then two powers, which would be the one that's going to power up the other side of the coil, and also the one that's going to be coming in on the common terminal. And so what I'm going to do is I'm going to bring that whirly board over here, and I'm going to let y'all work on that this afternoon, because you need to know about relays anyway. You know what I'm saying? You know which whirly board I'm talking about? You know the one that's got the whirling light on it? It's over there. Mm-hmm. I want that one brought over here. We're going to hook some power up to it with one of these jumpers, so you guys can actually work on getting that whirly board done. It won't take you long to do it. And I got a sheet on that too. that you guys have already supposed to have. Have you got a sheet, have you got your whirly board sheet? I gave you a worksheet on it, I thought. And it may have been one that you're supposed to do on live wire, and then you're supposed to do it for real on the board.
Oh, yeah, we had a minute, you know, concern.
Yeah, make it one, that's right.